believe I've got it recording at this point. What?
Says you're recording this.
All righty. Well, welcome to our VegOils 201. Kind of looking over the materials again this morning to kind of get reacquainted and get prepared for the call today. And kind of had to chuckle just a little bit because if you remember your college days and one of those 101 classes that you kind of enjoyed and the material was good, and not only was it educational, but it was kind of interesting to go through and listen to and study a little bit. So you took the 201 class only to find out that it was not nearly as fun and much more technically rigorous. And unfortunately, that may be a little bit of what we're in for here today. Not because it's not important, but maybe a little bit more, a little bit drier material, let's just say. So I guess with that as a backdrop, I will go ahead and get started. Really, we're going to focus on a couple different areas here today. Just some general pricing information. Honestly, we put this in the 201 because I have been through really from both sides of the fence, selling bulk refined vegetable oil and then working for a major CPG company as a buyer and really looking across the industry and looking at some of the RFPs that I have seen, certainly from the seller's side. I think for the industry to have a little bit better handle on how this stuff is priced, I think would certainly be helpful for all parties involved. We'll also spend a good bit of time today, and this gets into maybe some of the drier parts of the material today, but not only the different applications for different oils. As most of you probably know, oils are not infinitely substitutable one for the other. Some are pretty close, but there are actually reasons that we, in many cases, in different product applications, use different oils for different things in the food industry. So I'll talk a little bit about that and kind of what makes one oil different from another oil in different applications. And I'll talk a little bit to the price side of that because there's certainly a value component to that. It's what you're trying to get the oil to do in the food application. And of course, as is always important in corporate America, it's always at what price point. So that's really the two areas that we're going to focus on today. So let's just jump right into pricing. And I will tell you this, the pricing example that I have in here, first off, you can see when you look at the board price is pretty old. When you look at the basis, it's obviously got some age to it. Some of the prices that we've seen here in the last 2 years in the vegetable oil space are really like nothing that we've ever seen before. So, but at any rate, the pricing structure is still the same. And what we're showing you here today is just the bulk side. If you are buying a further processed product like salad dressing or mayonnaise or something else, or if you're buying a packaged product, you clearly below the bottom of the line here that we're showing you today. You have to add on, packaging costs and freight and all those other sort of things. I just wanted to get you the bulk side of it so that you could kind of understand it better. We talked about the board. We've talked a good bit about that. That's the Chicago Mercantile Exchange futures price that most of you are familiar with. Used to be called the Chicago Board of Trade, but that's the board price we talk about. You've got a cash basis. Now that's a negative number that I'm showing you as an example. That is cash crude is what I'm showing you in here. It's not your refined oil basis. I'll get to that and how it's calculated here as I go through this, but that is your crude oil equivalent. I get asked all the time, well, since the futures price is a crude oil equivalent, why is there a basis? It's an excellent question. It's always a difficult one to answer, but soybean oil is produced and consumed everywhere on the planet. And the Chicago Board of Trade price is a price where par, or even to the board price, is in one location, and that would be Central Illinois. And so you can't have the same price for soybean oil everywhere in the US and everywhere in the country. So there is a basis adjustment. Now that basis moves, it moves up and down a little bit over time, but that's what the basis is. So when you take the board price and you add or subtract the basis, that gives you a crude oil price. Now let's just say that this is a crude oil price for the sake of this example, somewhere at what we would term a Western refinery. Refinery in Des Moines or Lincoln, Nebraska, or St. Joe, Missouri, or Council Bluffs, Iowa, just kind of a general location like that. So this would get you to a 34-cent crude oil price. Well, when you're refining crude soybean oil into a edible food product, i.e. refined soybean oil, RBD soy, as we talked about it last week, you're going to experience refining loss. Now, one of the discussions that I've had when I was on the sell side, speaking with somebody that was a buyer, I had a buyer one time, I've had several buyers tell me over the course of my career, well, I don't want to pay for that refining loss. That's your problem. And my somewhat smart aleck retort was, well, if I leave those impurities in the oil, you're not going to like how it performs in your food product. Basically, the point here is you have got to remove those impurities. That is what makes up the refining process. It's not something that it is defined as a loss, but it's not actually product that is lost because of a poor job that someone would do refining. It's actually removal of the impurities in that oil that make it not an edible product. When you're talking about soybean oil, a big part of that is what's the industry terms heavy gums. Some of those can be further refined into lecithin, but it's a lot of the impurities that would cause an oil to smell bad, taste bad, smoke in a high heat application. So you're going to lose about 7%. So if you take the crude oil price times 7%, in this case, that gives you about 238 points worth of refining loss. After that, you have to pay the guy that has the refinery to do the work of refining that oil, typically between his material costs and everything else. This is a little bit of an old number. I would say a number that's much more typical today. It's probably closer to 2.5 or 3 cents. A lot of energy in the process, a lot of natural gas, a lot of heat, a lot of heavy equipment. The price of everything, including energy, is much, much higher. So let's count this as a bit of an old example that I probably should update for the next time I do this. But you've got your refiner's premium in there, and then pretty much after that, it's just freight to get it to your location. Could be truck freight, could be rail freight. If it's a rail freight, it probably includes a cost for that rail car. That most of the crusher refiners operate their own fleet of rail cars. But that is basically the essence of it. And when you add all these things together, in this particular case, you get a price of just over 40 cents. Boy, wouldn't that be nice? And then all I do to get the refined oil basis that most of you are familiar with is I simply subtract the board price from that. This is a basic pricing structure for any refined oil. This is refined soybean oil. If you're looking at canola oil and you're starting from crude oil, the shrink will only be about 3%. But the percentage depends on the oil. If you're looking at corn oil, it's going to be closer to 9 or 10%. So really just depends on the oil that you are operating or that you are looking to do pricing on. I probably should have mentioned this at the beginning. I mentioned it at the beginning before we started our 101 last week. But if you have any questions as we go through this, don't hesitate to ask. We've got Paige here in the room with us. She is going to monitor the chat bar. That's where you could ask a question. So just click that chat bubble. It should be right in the middle. Should be right in the middle of the top of your banner here on your Teams window. Just click that chat bar, type in your question, and Paige will stop us here midstream and ask the question. So if there's no question, well, if you got any questions on this, by all means, type them in. And we will keep moving here. Now I've got another pricing example here. I am certainly not trying to confuse you. The reason that I put this pricing example in here, it's not going to make a lot of sense, but if I started trying to explain it from this one, we would have no chance. And the reason that I do this, well, go ahead.
I have a couple questions here.
Yep.
So the first one is, so the reason you can lock in basis price is because it's basically fixed, is the question.
The basis is not fixed. It does move a bit. This 200 under number here doesn't move an enormous amount, or at least it didn't used to back in the good old days, which I define as anything more than 2 years ago. It didn't really move a whole lot. In the Western US, it would 95% of the time it was between, on the high side, 50 or 100 under, and on the cheap side, maybe 250 or 300 under. And it didn't fluctuate that much. With the advent of biodiesel and renewable diesel that we spoke a bit about last week on our call, that basis number has gotten a lot more volatile, a lot more violent, but typically it doesn't move all that much.
So then the second question goes kind of along with that. Can you cover again how the cash basis number is created?
Yes, I can. I don't want to get too far off into the detail ditch here, but the reason that the basis didn't used to move very much, and I think at some point we will get back to those days, those good old days. But the futures mechanism has what is called a delivery mechanism. The futures market is a derivative market. It is a financial instrument that is used as a risk transfer mechanism, i.e., food companies, producers can use this to hedge some of their price volatility, some of their price risk. That delivery mechanism for soybean oil and all other commodities that have a futures market attached to them are designed to keep the cash market and the futures market somewhat tied together, okay? The delivery mechanism at par or at a zero basis, as I mentioned earlier, is in one place, Central Illinois. It's actually defined as Decatur, Illinois. When you get to most of the Western refineries, the way that the Chicago Mercantile Exchange has divided the US up for its different delivery mechanisms, is, when you get to the Iowa, there's a bunch of Western refineries and crush plants that are all grouped together. Chicago Mercantile they've got, I think, 7 or 9 different regions that they monitor around the US. And the delivery basis is about, depending on where you're at in the West, about $0.015 under the board. Why, you might ask, if it's $0.015 under the board, would a refiner sell at 200 under the board in my example? Well, honestly, you can't market all your product through the delivery mechanism. There's only a limited number of tanks, limited number of amount of volume of tank space available. So again, without getting too far off into the detail ditch, be glad to talk to you offline about that. Be glad to get you with the materials actually on the Chicago Mercantile Exchange website that can walk you through the details of the delivery mechanism. But that's kind of the gist of the answer to that question. So hopefully that was not overly confusing. Moving on to this second example. Well, I'm sorry, go ahead, Paige. Go ahead.
Is it fair to say that the basis price will get higher as the delivery is longer distance?
Yes, that is generally true. That is generally true. Some markets in the US, as you get closer to the Gulf, you get further away from Decatur down into the Southeast, can actually go to a small premium to par. The Chicago Mercantile Exchange actually has a bit of what they term, I think, a dynamic set of delivery values. Decatur, Illinois is always par or always zero basis. But what the Chicago Mercantile Exchange does is they monitor the amount of receipts, if you will, or the amount of oil that's actually in the delivery mechanism. And then they will adjust those delivery differentials at the beginning of January every year based on, if an area is getting too much oil delivered in it, they'll make the basis cheaper in that area. If there's relative to another area that's not having many or any deliveries, that one might go up. But that's how they continue to adjust nationally here to try to keep the delivery mechanism fair. Did I see another one pop up there? Okay. Thank you for the questions. I do appreciate them, and I think these things are always better when they're interactive. So why do I have a different pricing mechanism up here? Well, I've got in the quotes up there because we've always done it this way. Never understood it, always found it difficult to explain. But when I started in this business in the 90s, and some pricing mechanisms still work this way, they will, rather than calculating shrink as 7% of the total cost of the crude oil, they will start the shrink calculation at 20 cents. Now, you may ask, why do they do it that way? Well, the only thing that I've ever been able to come up with to answer that question is what I've got in blue at the top. I think it's one of those industry customs. The reason that you have to know this, and I didn't just put this in there to confuse you, was that I cannot tell you how many RFPs that I have seen in my day, especially on the seller side, where the buyer didn't clearly define where the shrink was calculated from. If you ask some crusher refiners in the industry for an offer to offer you oil this way, they will base it on 10-cent crude oil. Some will base it on 20-cent crude oil. Some will base it on 15-cent crude oil. And if you don't know where you're starting measuring from, you will never get to your destination properly. Now, this looks like less shrink. If you remember my prior example, 7% of 34-cent crude oil was almost 240 points of shrink. This one, it's 98. But look at the refining margin. That extra 7% of the first 20 cents, which if you can do the math in your head is 140 points, 7% of 20-cent crude oil is 140 points, is added into the refining margin. You could see that we end up at exactly the same place. I don't want to belabor this point. I simply show you this because as a buyer or as a seller in this industry, if you ever get involved with an RFP or you ever get involved with formula pricing for soybean oil, just know, if you remember one thing from this part of our conversation today, it's that you have to know where you're starting your shrink calculation from. It's that simple. So if we have any questions, does it look like it, does it, Paige?
Nope.
We are going to go on into the chemistry lesson part of this. Now, I didn't pick this diagram off the web to be unduly confusing, although it probably looks that way. You might also be thinking that I said at the beginning that we were going to talk about product applications. Why the hell am I getting into the molecular chemistry of a fat molecule or a vegetable oil molecule? Unfortunately, you can't know about the next thing that I'm going to talk about, which is product applications and why you use a certain oil in a certain application without knowing a little bit of the chemistry behind the scenes. Okay? You don't have to remember all these little things here, but you have to remember a couple things. First off, a triglyceride is a chemistry term for a molecule of fat or oil, vegetable oil. We have a question there? Okay. Why is it called a triglyceride? Well, tri means 3, and there are 3 carbon chains attached to a backbone of glycerin. That is simply what a fat molecule is. Now, you don't necessarily need to know that exactly, but I want you to look at these carbon chains. Okay? Now, to get this to fit on here, these are not exactly to scale. In most vegetable oils, these carbon chains are 18 carbon atoms in length. Okay? But I want you to look right here at this one. Now, I'm kind of giving you the answer here, but I'm going to ask you a trivia question. And I know everybody's muted, so you're probably not going to be be able to answer this. We should have probably had a prize on here for whoever pops the chat thing up first. But if you remember your chemistry class in high school or college, how many attachment points does an atom of carbon have? The answer is 4.
Oh, somebody popped in and said 4 right when you said it.
Very nice, very nice. You can see that each one of these carbon molecules is using 2 of its bonds to attach to the carbon next to it, and is using its other 2 bonds to attach to a hydrogen molecule. Why is that important? Well, everybody on here has heard the term saturated fat, I suspect. This is a fully saturated carbon chain. Every carbon molecule is saturated, has all 4 of its bonds saturated, 2 to the carbon molecule next to it, 2 to the hydrogen atom on the outside of it. This is what's called a double bond or an unsaturated bond, where the carbon molecule, the carbon atom, forms 2 bonds to the carbon molecule next to it. That is called unsaturated. This is an unsaturated fatty acid. Now, why is that important? Well, as we get into the applications, you all are familiar with saturated and unsaturated fat. We have been told for decades that saturated fat is bad for us. We have found out as the science has progressed that that's maybe kind of partially true in some instances, but not so much. But the other reason that that is important to us is because this double bond is much more subject to oxidation. In food company parlance, you might equate that with how long the shelf life is. You might equate that with rancidity. A saturated fat molecule might not be quite as good for us from a health perspective, but it is a good bit more stable in some of the applications. If you're using the vegetable oil that you buy to make salad dressing, probably doesn't need a lot of additional stability because it's not a high heat application. If, however, you are using that in a high heat application like frying or baking, that unsaturated bond can cause you more difficulties because it can break. It can be subject to oxygen. You could break that bond and have an oxygen molecule attached. In many cases, this carbon chain will break. And then you get this piece floating off here. That would be, by the way, called a free fatty acid. As some of you on the call probably know, that is probably one of your measure of quality. You want to have when you get a truckload or a tote of vegetable oil into your house and you're testing quality on it, one of those measures will be free fatty acid. That's a measure of how fresh this sample of vegetable oil would be. So it's that double bond is the reason that I show you this chemistry lesson today. So with that as a backdrop, let's get into the different kind of oils. Now, this too is probably a bit confusing, but when you look at different types of animal fat or vegetable oil or vegetable fat, each type of oil has its own, what we call in the industry, a footprint. In other words, if you consider that triglyceride that I just showed you, if you get a rail car or a truckload or a tote of this stuff in, there are literally billions of these triglycerides in there. And each one of those has 3 fatty acid chains, hence the tri on the beginning of it. And if you measure all those fatty acid chains by how long they are, how many links of carbon they are, and by how many, if any, unsaturated bonds they have, each type of oil has a little bit of a different makeup to it. Soybean oil is one of the more common. Let's look at soybean oil on here, okay? If you looked at soybean oil, it's going to be 10 or 11% what is called palmitic acid. What that means is a carbon chain that is 16 carbons in length that is completely saturated. It's going to have about 18 carbon chains that is completely saturated. It's going to be about 24% oleic acid, which is, those of you have heard the term monounsaturated. That is a carbon chain with one double bond, like the one I just showed you. And the rest of the soybean oil is what's termed polyunsaturated. It's going to have carbon chains that are have 2 or 3 unsaturated bonds in each one. Okay, I'm not going to read you this whole thing, but you can look across here and see. This can be kind of a resource for you. So what does all this mean to you? Well, one of the things that it means, and one of the things that you have to look at, and one of the trade-offs, is when you look at an oil or a fat that has got a very large percentage of unsaturated fat to it, the trade-off is that it's got a lot of unsaturated fat. We don't like to have that on our label. People consider unsaturated fat to be less healthy or they consider saturated fat to be less healthy than an unsaturated fat. As you know, monounsaturated fats and oils are considered the most healthy at this particular point. That too is the subject of some debate that I'm not going to get into today. But the oils that are more saturated are also generally more stable in a high heat application if you're frying in your restaurant. And that is really a big chunk of the trade-off as you get into the different type of fats and oils that are out there. So what I thought I would do now with the rest of our time here is I'll talk a little bit more about that, but then I'll get into the individual oils, why they're used, what applications that they're used in, why they are used in those applications, to give you a little bit of a better idea. This can be very helpful if your organization were ever going through a reformulation, whether you are looking at trading out one oil for a different type of oil. This will give you maybe a little bit of a head start within your organization to try to understand what might be a good place to look. I was involved in some of these reformulation, I was on quite a few reformulation teams at my last place of employment before I started this company about 18 years ago. Actually, a little over 18 years ago now. That was back when we were, the FDA had gotten rid of trans fat. Some of you may have remembered the old partial hydrogenated days when we used to use a lot of that and then we had to phase it out. And so we were looking at a lot of different things. And when you're in an organization like that, to be able to be part of a team like that can help guide the marketing people and the R&D people towards an alternative that may work as good or almost as good, or maybe better in the actual product application, but to be able to do that at a price point that doesn't break the bank is very valuable, really, in a lot of organizations. So, you have a question popped up there or not? Okay. This is what you're looking at on the current slide is maybe a little bit of a different way of looking at the same thing. But rather than breaking it down by the carbon chains, this breaks it down by whether it's just the oil is simply saturated and how much is saturated. The kind of the reddish bar here is the saturated part. Look at coconut oil. Some of you are probably old enough to remember this is probably not that long ago. When was coconut oil bad for you?
Not in my lifetime, I don't
Yeah,
feel
not your lifetime, but it wasn't that long ago that the health food police were trying to get coconut oil banned in movie theaters because coconut oil was horrible for you. Horrible, they said. They've since changed their tune on that a bit. But why was coconut oil horrible for you? Well, back in the day when we thought unsaturated equaled unhealthy, that's why. Look at how much saturated fat's in coconut oil. Like I said, things have changed just a little bit, but you're popping popcorn. It's a high heat application. And what do you need for high heat applications? Well, as you might suspect, coconut oil is quite stable in a high heat application like that. Um, Palm oil and palm kernel oil, very high in saturates. Matter of fact, I'm old enough that when some of my early days in this industry, back in the 80s, there was a doctor actually right here from Omaha, a Dr. Phil Sokoloff, that had a heart attack. I believe he had bypass surgery. He was trying to do the right thing and convince people that he was convinced that his heart condition and many of the issues of the day that we had with heart disease climbing rapidly was because we were using at that point quite a bit of palm oil with its very high saturates level. Again, this is a lot of science that has been a bit disproven since then, but you get the idea here with all the saturated fat that you have um, uh, quite a bit of stability, and at the time anyway, an oil that was seen as not very healthy.
You just had somebody chime in that said it was bad in the 80s, but good in 2020.
Yeah, that's a very excellent point. Things have changed. I always, when I'm talking to younger folks like Paige in the room here with me sometimes, and we start discussing science and current science, I am always quite skeptical because in my lifetime, I have seen the conventional wisdom, most time always for good reason, but the current science and conventional wisdom doesn't always tell you today maybe what it told you in years gone by. So I suppose enough about that, but you can start to see here why a lot of the vegetable oils kind of fall down here in the low saturates space. Canola oil is very low in saturates. Matter of fact, canola oil has gotten a very good connotation because not only is it very, very low in saturates, but it is also very high in what many people, and I believe much of the current science would tell you, is actually a very healthy oil, and that would be oleic acid or a mono unsaturated, mono meaning one double bond. So you kind of get the idea here, though, looking at the charts of what is got more saturates and what is less saturates. And this table right here, I think, can be a pretty good guide. Can be a pretty good guide at when you're looking at what you might substitute in a product application. So let's just go through, not all of those, but let's just go through some of those oils. Let's go through some of those oils and talk about what they might be used for. And I'm going to start with soybean oil because here in North America, soybean oil is king. Now, it's not king because it's the best oil for really about anything. It is king because we make more soybean oil than we make everything else combined. There's a lot of it, and it's generally because of that, cheap. And if you were on the 101 call last week, I also told you that the one thing that makes soybeans different than any other oil seed, or just about any other oil seed, is that as we make and crush soybeans for the high quality protein soybean meal to feed to our livestock, and the oil is, I don't want to say a byproduct because the byproduct part, the oil today, is what's carrying about half the value of that soybean. That's a little bit unusual if you remember last week. Typically it's about a third, but we have a lot of it. We're making the bean for a different, we're growing the bean and crushing it for a different reason. And so there's a lot of it. So what is soybean oil the best at? Well, the honest answer to that is probably nothing. But it is the most prevalent, it is the least expensive, and it is also the jack of all trades oil. It is very, very good at just about anything you want to do with it. What do we use soybean oil the most for in this country? Well, probably I would say it's hard to, they don't publish statistics on each thing, but just about everything. So certainly salad dressing is a big application for soybean oil. Soybean oil has just enough saturates in it that it is used in some frying applications. Soybean oil is used in a lot of baking applications. To be honest with you, soybean oil is used for just about anything. It can be used for just about anything. So what do you have to be careful with soybean oil in? Well, Sometimes some high heat applications, because it's got a relatively high number of polyunsaturates. Those have a tendency to break down and oxidize relatively quickly. And so some high heat applications, it doesn't work very well in. Some high heat applications, frying applications, where you have a lot of oil pickup, it can work okay. And what do I mean by that? Well, before the oil breaks down and goes rancid, you pick a lot of it up in the frying application, in the French fry or something like that, so that you're really not ever having to stop and throw oil away. It's kind of picked up and replenished before the oxidation necessarily happens. But you have to be a little bit more careful in a high heat application. One of the other reasons you have to be a little bit more careful in a high heat application, and this is another variable that I haven't talked about yet, but it's also important. And that would be, as the oil does start to age, as it does start to oxidize, especially in a high heat application, different oils will start to throw off different odors and flavors. They'll impart flavors to the food. They'll impart odors when they're being used in the application. And those associated with soybean oil as it oxidizes are not typically seen as pleasant. Now, they're not horribly unpleasant. I'll get to some more of that here in a little bit. But they have been described as beany or grassy. Now, when you're looking at a product application, how do you know if that's okay or not? Well, kind of depends on what you're making. If you're making something that's got a lot of other flavors, a lot of other spices already built into the recipe, that's going to mask some of those, you might not be as concerned about it. You're making something like a potato chip, where that flavor you want from the potato to come through, it might be a little bit more objectionable in that type of application. But it really, whether that's going to be a big deal in your application or not, is going to be determined in large part by what it is that you're actually making. So soybean oil, I guess the takeaway here is soybean oil is probably not the best oil for anything, but it's probably an oil that is, first off, it's going to be the least expensive or very close to it. Almost all the time, it is always very readily available, more so than a lot of these specialty oils. And it's probably going to work or have a pretty good chance of working in just about whatever you're doing with it. I'll get into some of the other oils here just a little bit. Let's talk a little bit about canola oil. Now, I'm going to back up a couple slides here. So when you look at canola oil, it's very low in saturated fat, but remember, almost 60% of these fatty acid chains have only got one double bond. So it's actually a reasonably stable oil in a frying applications. If you look at total bonds in a sample, it's going to have less because it's pretty low in polyunsaturates than even soybean oil. So it might even be a bit more stable in a heavy frying application. It is also an excellent oil for a salad dressing application. There are quite a few, there's quite a bit of business actually, I think, in North America that will actually switch back and forth. They might have it on their label, either or type labeling, or have different labels that they can switch back and forth, because occasionally, not most of the time, but occasionally we will see canola oil actually priced a little bit cheaper than soybean oil. Now, I would say over time in the central US, that's probably less than 20% of the time, but it's in North America, it is the second largest produced oil. Therefore, most of the time it is reasonably competitive with soybean oil from a price standpoint. Like I said, most of the time a little bit more expensive, occasionally a little bit less expensive, but it typically doesn't vary a lot. So let's talk about the high heat applications again. Typically, canola oil is not used without being blended. I'll get to that in a minute. In a high heat application. Well, why is that? Relatively stable oil, maybe even a little bit more stable than bean oil. One of the reasons is this flavor and odor reversion that we get on canola oil. It is referred to as fishy. Not good if you're making potato chips, probably not good if you're making French fries. Um, However, if you're making something that's got a lot of other flavor in it, I have heard of actually fast food restaurants that do fish that might use this as a blend or as a straight oil. So it really depends on what you're making with it. But typically, canola oil, rapeseed oil, is going to be used for salad dressing. It's going to be used for something like that. So I don't see any questions, so we will just keep moving. I do have butter in here. I did want to talk a little bit about the animal fats. Clearly, butter is going to be used much more in a specialized application. Butter and olive oil are really only a couple of the oils that we would use without those being deodorized. You remember I talked last week about the 3 steps: bleaching or caustic refining, bleaching, and deodorizing. Olive oil and butter are really 2 of the only fats and oils that we will really use in a significant way. I guess tallow might be considered the same way, without being deodorized typically. And that's because they impart very favorable, as you know, with olive oil and butter, very favorable flavor and odor characteristics. That's why you actually use those oils. Butter is very high in saturated fat, as you know. Again, back in the day, back when I started in this industry, butter was seen as horrible for you, absolutely horrible for you, because not only was it loaded with saturated fat, but it also contained, because it is a fat that is derived from an animal, it actually has cholesterol in it. We have since learned that ingested cholesterol doesn't seem to find its way to our serum cholesterol as humans. But we did not know that 40 or 50 years ago. So anyway, that's butter. And corn oil is another popular oil. Now, when you look at the makeup of it, corn oil has got low saturates. It has got a tremendously large amount of polyunsaturates in it. And so from what we've talked about for the better part of the last 30 minutes, that means that it is not a very stable oil in high heat applications. So what do people typically use corn oil for? Well, one of the things that it is used for quite extensively is corn chips, potato chips. Now you may say, if it's not a very stable oil, why in the world would you use it in a high heat application? The answer goes back to the flavor and odor reversion characteristics. Corny is typically when corn oil oxidizes, when it starts to go rancid, when it starts to get beat up in a high heat application and these double bonds start coming apart, it will impart a very corny flavor or odor. Obviously, if you're producing corn chips, that's not only not a bad thing, it can be a very good thing. And so the flavor and odor characteristics that come off of it are seen as very favorable. Cottonseed oil is very much the same way. Now, cottonseed oil is higher in saturates, but cottonseed oil also will impart some very favorable flavor and odor characteristics. One of the things that I should probably mention as we get off into more of the specialty oils.
I have a couple questions.
But tell you what, I'll stop there and take a couple questions here. Yeah.
Okay, so we had one that says, when looking at market reports, bulk corn oil is at a premium versus other oils. What's the key driver there? I'm assuming yield is lower and therefore supply is lower.
Yes, that is really a very, very good question. So read it to me again, because there's pieces of it.
I'll read the first part. When looking at market reports, bulk corn oil is at a premium versus other bulk oils.
Yep.
What's the key driver there?
The key driver to that is, you're correct. It is just simply we don't produce as much of it. Typically in the US, we're going to produce 2 or a little over 2 billion pounds a year of edible corn oil. To give you some perspective, we're going to produce around 25 billion pounds of soybean oil. So that's a big part of it. The other reason, corn oil, believe it or not, is a byproduct of a byproduct. We don't grow corn for the oil. We grow it as animal feed. We grow it to process it into sweeteners and ethanol and starches. One of the byproducts of removing the starch to make one of those other three products, ethanol, cornstarch, or sweeteners, is we pull the germ out of it in the wet milling process. That corn germ is where the oil is. To give you some perspective, if you remember the 101 last week, a 60-pound bushel of soybeans contains about 11.5, 11.6. Last year, it contained over 11.8 pounds of oil. A bushel of corn only has about 1.5 pounds of corn oil in it. So that's the primary reason for that. When we look over time, and again, I would argue that the last 2 years are not representative of anything when it comes to commodity pricing. They've certainly been the anomaly. We used to look at it, if you're looking at bulk delivered product kind of into the Midwest here, corn oil would quite regularly be, a 4 to 8 cent premium to soybean oil. As you know, if you've been using corn oil the last couple of years, it has gotten to be a much larger premium than that of late, but that used to be what was historically typical.
Okay, and then I have another question. It says smoke point question. Can you explain this? And what should we think about with this parameter, frying or deodorization, etc.?
Well, smoke point, that's a good question. Smoke point, some of it is going to be how stable that oil is. In other words, I think a smoke point on corn oil, I suspect, is probably a little bit lower, especially in a really high heat application, simply because it's got more double bonds that's going to cause that oil to come apart more. Another part of it is the refining process. When I say refining, all three steps: refining, bleaching, deodorizing. If an oil is not properly refined, it's going to have a lower smoke point. If an oil is not refined, like olive oil, which I think might be on here next, look at how much lower smoke point is on that olive oil. That does not mean that olive oil is an inferior oil. It just means that it is not refined. We consume olive oil in an unrefined state. It is filtered, but it is unrefined because it has very pleasant flavor and odor characteristics. We cook with olive oil because of the way it tastes and the way it smells. But because it is not refined, it is going to have a considerably lower smoke point. Hopefully that made sense and answer that question. Olive oil obviously is very unique. It's kind of like butter. It's got its own deal that we use it for. We use it for the flavor. We use it for what it smells like and the flavor it imparts to the food. Why don't we use it for more high heat applications? It's not real high in saturates, but look at the monos. Look at the mono unsaturates. Olive oil is actually a quite stable oil. And when we use olive oil, not extra virgin, that is unrefined, but when we use a refined olive oil, it can actually be a very good, very stable oil in a high heat application when it is refined. Obviously, we don't refine the extra virgin stuff, but the second press, some of the other product that is not good enough to be called extra virgin olive oil that is then refined can be a very good oil in product applications. The other thing that I will say about olive oil is it's got some very positive label implications to it. A lot of people perceive higher quality when they see olive oil on the label. A lot of people perceive something that's going to have, even if it's a refined product that has therefore no taste or odor to it. A lot of people think that they're going to get some of those pleasant characteristics that are very much associated with extra virgin. So this can be a very good oil in a lot of different applications for those reasons. One of the things that I probably need to mention here, as I get into the specialty oil stuff, now I'm not going to get into the high oleics today, but I'm not going to get into really, I don't know that I've got sunflower oil in here and we're going to kind of run out of time. But one of the things that you need to understand in a food company when you're looking at these things And one of the things that when I was on these reformulation teams at my past life at ConAgra, that I would always try to help the team get to that correct tipping point between price and what it did to our product and supply chain. We've all been through supply chain purgatory here in the last 2 years. And the problem, if you just let, and I'm not throwing R&D people under the bus at all, I don't mean to do that, but one of the problems that you get into, I can't tell you how many times I've seen at food companies where they will come up with a product specification that is what I term a white elephant. In other words, it might be the absolute perfect product or blend of products to make that particular finished product, but it is going to be so incredibly difficult and expensive to source that you can end up not only paying a very high price, but you can have supply chain issues. The more components you have to a blend, generally speaking, the fewer people that are going to be able to put it together. And honestly, some of these oils, I talked about corn oil a little bit ago with a, 2.25 billion pounds a year of annual production, less than a tenth of what we make on soybean oil. Most of these other oils, whether it's sunflower oil, whether it is high oleic canola, high oleic soy, it is much, much, much less than even the corn oil. Cottonseed oil is another one. We don't even make 1 billion pounds of cottonseed oil in the US in a typical year. Nothing wrong with those oils, nothing wrong with sunflower oil. They are wonderful products, but you just have to be a little bit more careful, because the other thing is not only do we make less of them, but with a product like, well, corn and certainly soybeans, we grow those across the whole Corn Belt. The whole Midwest is producing those. When you get a product like sunflowers, you are growing it literally in 2 states in the US. Well, 3, I guess, if you count Kansas, but almost all of it is grown in North and South Dakota. As you saw year before this past growing season we just got through, we had a drought in that part of the country. You have a much more isolated area, which a much, much higher percentage chance that you can have a dry growing season. It's hard to have a dry growing season across the whole Midwest. Happens once in a while, not too often. You can have a dry area much more frequently in a more isolated area. And that's the one thing that you kind of have to be very careful of with many of these specialty oils. Again, I am not trying to dissuade you from using them. I am simply pointing that out as a potential supply chain and cost issue. Also pointing out that when you do find one of those oils, corn oil, sunflower oil, some of these high oleic varietals, they are great in some of the product applications, but in many sources, if your team is going to spec those products in, it is often good to have an alternative that you have already picked out that you can switch to in a year like last year when our sunflower crop just was decimated by weather. So just a point that I'm trying to make on those as we get through it. So let's get into palm oil. Palm oil is, I believe, number 3 on the usage here in North America. It is number 1 on a bullet when, as I showed you last week, when it comes to production and consumption in this world that we live in. But palm oil is different. Palm oil is different. All the oils I've showed you so far outside of butter are liquid at room temperature. Palm oil is a semi-solid at room temperature. What does that mean? Well, you sure don't want to put palm oil in your salad dressing or you won't get it to come out of the jar. It is a very, very, very good oil with that level of saturates and that level of monounsaturates. It is a very, very stable oil in a high heat application. It is also used primarily when you need a structural fat. What do I mean by structural fat? When you need something that is solid at room temperature. If you try to make margarine, for example, out of all liquid oil, you have a tough time making a stick of margarine. You need something for those solids to be in there. And that's why palm oil is used in many high heat applications, heavy frying, blanching French fries, many applications like that. It is also used where you need a structural fat, a shortening in some baking applications. I mentioned margarine. Much of the margarine that's produced in the US today is using palm oil for the hard component of that so that you have that structure. If you need it to hold together in a stick or even for a tub margarine, you need that structure. That is what palm oil would typically be used for. Because it's the largest producer of the world veg oils, it is often one of the cheapest as well. Now, as I showed you last week, it is produced on the other side of the planet. So often by the time you ship it to the US, sometimes it's a little cheaper than soybean oil. A lot of times it's a little bit more expensive, but it's typically very, very cost competitive as well. And you can almost always get it. The only time we've had issues with that here in the US, a lot of time that's shipping issues or something else going on because we got to, again, get it from the other side of the planet to here. But a lot of these others, palm kernel oil and coconut oil, these are very specific fats. I talked about the high saturates. The other thing about coconut oil is because the way that it is, it comes out of from Mother Nature. You've heard of melt in your mouth, not in your hand. Coconut oil typically has a very steep melting curve. This is why it is used along with palm kernel oil many times in the confection business. If you want something that is very solid at room temperature, but that very quickly will melt away to give you that good mouth feel. Again, the melt in your mouth, not in your hand. That is what you would use coconut oil and largely palm kernel oil for. And I talked about some of the other specialty oils, cottonseed oil, sunflower oil. Those are wonderful oils. Frying applications, sunseed oil, like cottonseed oil, when it does start to come apart in a high heat application, has very favorable odor and flavor characteristics. But again, some of these oils are, when you look at the production in the US, they can be very, very difficult sometimes to source. Very wonderful oils, very difficult to source. I didn't actually talk about some of the non-GMO oils. I know that that's very popular as well on a lot of labeling concerns, but I will also tell you this. Those have come, especially last year was the poster child for a rough year. Sourcing non-GMO oils. Again, they can be a little bit difficult. Again, I hope you guys, the takeaway when I'm saying this about some of these specialty oils, I hope you don't perceive that as me trying to steer you away from them. Anything but. They're some wonderful oils. Just you need to be signaling to your organization when you're looking at some of these oils. You just need to be signaling that, hey, some of these can prevent supply chain issues. They almost always present cost issues. And we need to go into it with our eyes open from a cost standpoint and a cost volatility standpoint. We also need to be ready and prepared in years where we have supply chain issues. So that is just about the top of the hour. That is where I think I will leave it today. We certainly appreciate everybody joining us. Anybody who registered for this webinar will get a copy of the slide deck along with the YouTube video with my audio. And it doesn't look like we have any more questions, do we?
Not that I see.
Okay. Well, thank you again for joining us. And as always, be careful out there.